Right, we've got multi-person presentation now. So talked about this before. This is the LowCO project up in Auckland, and we've got Nicola from Fletcher Living, sustainability person there, and we've got Tim, who is architect on this, and Jason, who is involved in lots of ways. I'm sure he'll tell us about. I'll hand over to you guys.
Kia ora koutou, I'm Nicola. I'm Head of Sustainability at Fletcher Living. I heard Sarah say this morning that housing developers are doing it over there and we're at now a pivotal moment of change. So I thought, well, here I am, a volume builder from Auckland speaking at a FINS conference. So perhaps we're at the same pivotal moment of change. So thank you very much for having me. It's a pleasure to be here. We're doing a three-part harmony today, the project team. And I like to joke that for the last 3 years, I've actually had 3 children, not these two. No, a son and a daughter, and then LowCO. So the LowCO baby phase, look, you know what it's like. It's messy, it's chaotic. There's lots of endless questions that are asked, and it always costs more than you expect. But as we've moved through into the teenage years of the project, the baby's grown up, still needs a little bit of supervision, but it's got a high amount of potential and promise. So you may ask, where on earth did this project come from for Fletcher Living? And it really came from a talk that we heard from Brands and Massey University. We knew that carbon was a critical challenge for the building and construction sector, who's responsible for 20% of all carbon. But what the team did from Brands is they calculated the available carbon budget. And then they, in a series of steps, they drilled it down to the available New Zealand budget, the budget for the residential sector, right down to the budget for a single family sized home. And that was just a mere 39 tonnes. And to put it in perspective, an average New Zealand home can produce 270 tonnes of carbon equivalent. But, here's the actual kicker, because since 2020, the size of the carbon pie and then the size of the slice has reduced even further. And it's not like the residential sector has geared up and started building homes with a lower footprint. So we don't have any additional years of carbon budget left. And also how important the decisions we make today, what those consequences are for the decades to come through 90 years of a home lifespan. So that really gave us a target and a challenge. Could we design and build a 3-bedroom home that would fit within that radically low carbon footprint? And could we use low emissions materials that would avoid that upfront carbon emissions that perhaps could never be recovered? So the project started with that decision to progress through design and construction through a lens of total carbon, and that really directed a lot of our choices. So that was the singular focus from the beginning, and that really informed our decision to not go for Passive House certification. But it's very fair to say that Passive House provided those essential tools and methodologies that helped us achieve that total carbon target that the project was striving for. And Jason will speak to that in more detail. And so I'll fast forward through 18 months of design and then construction, which took place between May 23 through to January this year. And yes, we achieved the 7 times less carbon. And I'm going to share the secret sauce with you right up front. It was actually the fact that we had a multidisciplinary team of consultants. We had us as developer working alongside public entities like Auckland Transport and Watercare. And we were all united with the same goal and the same shared purpose. So as part of the LowCO project, it was pretty unique in the fact we had architectural teams, landscape teams, design, manufacturing, fire, structural, energy modelling and carbon modelling. And those people were all iterating across their disciplines to target that lowest practical, embodied and operational carbon. And I think it's really fair to say that design teams often don't get that opportunity to really look over their designs and test through different scenarios, determine their trade-offs, and optimize so many inputs in a building. But look, that's the happy ending, and the start looked more like this for Fletcher Living. But, we had Jason and his LCA quick assessments. We had Tim with his WIP plan sets, and soon that folder started to grow. So Jason, over to you.
All right. So taking a step back to a bigger picture, this project was a bit of a dream in that it started with, well, let's model it and figure out where the carbon is, and then move the design forward, which is a really unusual place. We're actually in a position now as a society across Earth, where we're going to basically redesign our whole economic and social system based upon a computer model of how the climate's going to change if we add a whole bunch of CO2 to the atmosphere, right? So literally, like they talk about at the UN, they're going to basically move the whole world. Everyone's going to change the way they live, or we're not, and we're going to know why, right? So this project, Sustainable Engineering was brought on board, and Toby Brook in our firm did most of the LCA quick work for this project. So he's unfortunately moved on. But the plan when we came on board was, how can you go ahead and find a path forward with a model to look at that stuff? So the very first thing we did was look at the target, and then put together a model that looked at operational carbon and embodied carbon, using as best we understood at the time what the MB standard would be, which changed during the process, to loop through that model with the design team to make sure that we could get what we wanted to get at the end. To me, this is what enabled the project to work forward. I won't go back too much to Cold War stories, but that's how we got a lot of industrial war structures to work too, is building big integrated models that allow you to make big changes. A lot of times it's not a transformative change in one particular part of a thing, it's how things interact. And with Pascal's planning package and something like LCA Quick, or a simplified tool like the Carbonator, which was what was used originally in this project, you can loop through those models. So an example for this was one of the very first trade studies we presented. I took and colored the graph up so it was less complicated, but the operation, so we basically looked at operational embodied carbons. The operational is in blue and the embodied is in red. And this is over 90 years because it was one of the first studies we did. And obviously the first thing that taught us was efficiency first was a good first step for the project. And then you start looking at things like timber floors versus slabs, different enclosure elements, claddings, all that sort of stuff. Moving forward, we then looked at, well, what's the trade-off look for early materials trades? When we looked at the final results, we're like, we can't get to 39 tons pretty much no matter what you do with materials. So what do you do with PV panels? We spent quite a bit of time in our firm looking at PV panels and trying to make sure we had actual realistic embodied carbon from PV panels, because there's a lot of that story of how much carbon is going into those panels, how much embodied is into those panels is quite an ongoing story. And recent data is very different than 10 years ago. So was our piece of the trade, was to look at this integrated model across the building with the trying to track towards carbon. And then we had the architectural team.
Yeah, so just to be clear, when we talk about the LowCO project, this kind of the focus of the project was the standalone home, which you can see here. But we also, at the same time, developed using a very similar recipe, a terrace block, which involves 3 homes there. So in total, we've got 4 homes, which Fletcher Living are monitoring to see how they now perform. SGA architects, Strawn Group architects, were prepared the original concept design for the LowCO house, which Archetype then took on to detail and prepare the energy model for. SGA designed a really compact house that had great orientation, had eaves on the north-facing elevation and deep verandas on the west and east. And our challenge was to detail it in a way that would radically reduce the operational energy demand as well as reduce embodied carbon at the same time. Of course, we drew on our Passive House experience and adopted a fabric-first approach based on energy modelling and Passive House planning package. We had a focus on high levels of insulation, thermal bridge-free design, air tightness, and integration of heat recovery ventilation. This project had a number of unique constraints which required us to develop a new suite of materials and details. The first of which was the fact that it was going to be fabricated at Clevercore, and the Clevercore factory, they basically build the timber framed panels out of 90mm framing with studs at 400 centres. They come with the insulation already in there, the plasterboard already on the panels, the windows already installed, and then they go to site. So we were then basically working with, didn't want to change the system too much, so we were basically working with that. Second constraint was that we wanted to develop an approach which could scale beyond the pilot. This meant that we endeavoured to find useful, we intended to use low-cost, local familiar products and systems wherever possible. And the third constraint was that every selection we made needed to have very low embodied carbon. And so this meant predominantly using natural wood-based durable materials. So the first move was to do away with the ubiquitous New Zealand concrete slab in favour of a traditional suspended timber floor. In this case, we tucked some rainwater tanks underneath there. That's what those blue things are. We just went with a cost-effective truss roof, added a little extra insulation and an Intello air tightness membrane under the bottom quarter of the trusses. We lowered the ceiling and the laundry to provide space for the Passive House certified heat recovery ventilation system and ducting along the hallway. For the windows, we chose the newly released APL Centrifix window system, and these windows provided New Zealand-made thermally broken windows which sat back within the insulation line. We modelled the project in PHPP and found that we could achieve Passive House performance in Auckland by sheathing the project, the Clever Core wall system in a 40mm layer of Styco wood fibre insulation, and this happened on site. So that's a sort of a standard window detail, noting the insulation in line with the windows working very neatly. One of the key decisions we made early on was that we would use the external jib weatherline layer as our air tightness layer, and that meant that we could run our services with 90mm timber framed wall without having to worry about penetrating our air tightness layer. From a sequencing point of view, this meant that we needed to pass the blower door test before we could clad the house because the air tightness tape was actually on the outside of the house. And a lot of you might look at this detail and go, oh, you know, what about the 2/3, 1/3 rule? Surely you need your air tightness layer further back to avoid interstitial condensation. But we modelled this in WFI and found that in the Auckland climate, it was an acceptable approach. So here's a few shots of the air tightness strips being placed on. They get taped onto the face of the weather line on the outside, and then they connect with the Intello in under the trusses on the inside. So it's that slightly different approach to what we would normally see. And again, here's a nice view seeing all of those strips of Intello and Exosana on top of the wall plates there before the trusses went in. So essential to get those kind of sequencing stages right. I think we've got a time lapse here of project going ahead. So some of the stages flash by. I mean, you really can't spot when the weather tightness on, and then we didn't even see the Styco go on. It basically was on so quickly that and then wrapped up, and then the cladding on.
So weather tight, shell and core within 1 day.
Yeah, incredible. In fact, you almost have to extend the video at that 1 day to sort of see how the house went together. There we go. The next one. For a cladding, we selected a WeatherTex Natural. WeatherTex is a fantastic cladding product made from waste timber and wax compressed into a sheet material. And given that maintenance contributes so heavily to embodied carbon, we were looking for a cost-effective cladding material that could be left to weather off naturally and not require ongoing staining or maintenance. SGA's original concept, a portion of the upper cladding was intended to be profiled metal. Sort of the upper section there, but when we looked at the carbon impact of this, we found that there was 1.3 tonnes of embodied carbon just in that metal cladding alone. So we made a number of changes along the way to try and push those embodied carbon numbers down. I really like this photo. I understand that this is all the waste that came from the fabrication of the structure of the building. One of the huge advantages of building in a factory is that you can all the little bits of wood get used up to make trusses and things like that. So huge benefit of off-site manufacture. Here's a shot of the inside. Note the absence of carpet. That was a decision made to avoid carbon impact there. Reasonably unusual to see that in a new home in the bedroom, but maybe something that will needs to become more common in New Zealand as we move forward. And there's a shot of the completed home and a shot of the completed townhouses, which, other than being on a concrete slab, basically had exactly the same recipe. And then there were a number of, do you want to talk about the water features? Yeah.
So I thought just to conclude, there'll be 3 areas that you may find quite interesting. One is the intense focus around water efficiency. And we formed a partnership with Watercare for this project. And so in addition to the carbon target, we were also wanting to make sure that we were fitting in with that MB water use target of 75 litres per person per day. And so we have learned a lot through this with Watercare. It's spurred many meaningful conversations about the importance of reducing water consumption on the private side of the meter to reduce the total system's emissions. And you know, this benefits the community, but also the individual homeowners too, because in Auckland, residential 3 waters are billed and metered at a household level. So the carbon modelling which Jason completed, it really highlighted that water connections to a home are very carbon intensive, both from an embodied and also an operational perspective. The disposal of black and grey water is really significant. And so by making this carbon cost of water visible to developers like us and also Watercare, and then proving how we could mitigate it, we're hoping that LowCO will have an immediate influence on standard practice. And it's really encouraging because those early stage policy conversations are starting to happen, looking at green IGCs, looking at rebates that recognise that there's reduction on the private side of the equation, and that really also reduces the draw and the discharge of water. So overall in LowCO home, we are looking to reduce water by over 80% in the house. So that's 80% of potable water used. And the terraces, we're expecting 50% less. And so this is really achieved through a combination of different factors, but harvesting and storing water, huge, reusing as much water as possible, and then just simply using less. And so a key thing for us is looking at that heat pump hot water system. So as we know, thermal performance is improving, and so domestic water use then becomes an increasingly large proportion of the energy load. So it was a really easy choice for us to go for a heat pump hot water. We've got rainwater tanks. So as Tim mentioned, under the suspended timber floor here, we've got over 8,000 litres of storage. They take the form of aquacomb pods, which click together like Lego for adults. And then we've got carbon and UV filtration. So whenever you've got water in those tanks, it's coming out all of the faucets in the house. Low water use fixtures and fittings, of course, but then we've also used low water use appliances. So for instance, we've got a 10-star heat pump condensing dryer unit in the homes. And then we've got a very interesting unit called Hydroloop, which is an advanced grey water recycling system from the Netherlands. So it's sitting in the laundry there and takes up the size of a fridge. And it's effectively using water twice. It's self-cleaning and it's got a 6-step treatment process. So it takes the water from the bath and the showers, runs through the system, and that's going to 3 places: into the toilets, into the rinse cycle of the washing machine, and then to irrigate the garden. So we then started looking beyond the walls of the house into the on-lot landscaping. And we know that as developers and designers, we're also responsible for those carbon values in the landscaping as well. And we were very surprised to hear how big they were. So we had Craig Pocock from Wellington. He runs Design Environment. He's one of New Zealand's experts on low carbon landscaping. And we said to us, look, do a calculation. We're building about 400 duplexes and standalones across our portfolio. And he found that for every single house, there's about 2.2 tonnes of carbon associated with that. When you start looking at the carbon footings along fence lines and patios and driveways, it really starts to add up. So we're now starting to go beyond the concepts of architecture into environmentally responsible residential development across the entire lot. And so we've started to get into the concepts of biodiversity, community food production, sustainable stormwater management, and how we build more community connections within the landscape. And so what we've found is that there's really significant opportunities to build other value within that landscape envelope. So for instance, we've reduced the carbon footprint by 30% in our on-lot landscaping. We've gone to do things like return to the 1970s with the split driveway and planting down the middle. We've reduced the toxicity levels significantly through just careful material selection, like the use of macrocarpa on the deck there. And then we reduced the impervious surfaces by 75% overall to reduce rainwater runoff and the urban heat island effect. All of the plants were chosen for their ability to provide food for insects and birds across all 4 seasons. We had a particular focus on the winter months too. They had very low irrigation requirements. In fact, there's no irrigation system which has been installed. We've had trees and vines. We selected that to create an edible landscape. So lots of fruiting trees, but we've used vines on all of our sunny fences to build passion fruit and raspberries. And that's really in the hope of encouraging neighbours to talk to one another and share and swap fruit. We've had a meadow. We included a meadow into our build here. So this was selected for low carbon maintenance costs, but also a very high carbon sequestering value and positive ecological, stormwater and visual cues as well. That bottom left-hand photo is the meadow taken last week. It's really starting to develop, grow. The tenants who are in this house, she enjoys picking a flower every day to take to kindy, which is really sweet. We've kept a 30-centimetre grass strip along the edge to make a nice tidy condition to the footpath. And I'd like to draw your attention to that footpath. That took 3 months to get through Auckland Transport, but it's a very low carbon concrete. And we proved that strength and setting was just the same as were aesthetics. And this has led to a practice note being developed by Auckland Transport to allow low carbon concrete for vehicle crossings, joels and footpaths. So well worth the time and education invested in the project. So the LowCO monitoring system is all in place. We have become landlords and we've tenanted all 4 homes. And we want to test our assumptions about energy and water use there with real people over several seasonal cycles. So we'll have this in place for at least 3 years. We've got a real-time dashboard. This is a screenshot of it on Friday when I put this slide pack together to make sure it's hot off the press. And that's really in the hope that we can show the people who are living in the homes when and where their water comes from. Is it from mains, tanks, or recycled grey water? You can see there we haven't actually had to pull through the main supply yet. So it'll be really great to see how that shifts over into the summer months. It's also going to show in a granular way that cost and carbon consequence. We're hoping that the occupiers of these homes are going to take more of an active role in managing their consumption overall. For instance, they're only doing washing when there's recycled grey water in the tank that's made available. And we're hoping that will advance that consumption literacy with our people, because that's quite critical to the success of this project going forward. We've also found that our customers, they care less about their watts and litres. They're more interested in weighing the value of their decisions against dollar terms, more money in their back pocket, less money on the utility bills. And we're hoping that this shows what they are spending it on. I think it's important to note that high performance is very sensitive to people. Our tenants, we've been finding, are just not putting enough heat back into the building. You can see there we've got the temperature slightly lower than what we expected. They weren't putting the heat pump on. They haven't been used to running a heat pump continuously. So a lot of this is about educating our clients and our customers that you will spend less by putting it on more continuously. So really to conclude, I think that energy cost lens is much easier, but that carbon cost lens is much more tricky. It's also not as common, but the size of the prize here is really huge. So the big question in my mind is, how do you actually turn on the mainstream? I know that we've lifted our sights as a developer. We now know what high performance looks like, and it's about now taking this from 4 homes into the 996 other homes that we're building each year. We've proved that there's many levers that you have to pull to be able to decarbonise. And a key part is that we still need to sell homes. And so balancing that high performance with what someone willing to pay isn't actually that easy. And it's often quite hard to do education at the point of sale. So what we're doing is we're running a comparison of costs and associated carbon savings over the home's lifetime, so CO2 saved against dollars spent. And that's going to be a really fascinating exercise that we're doing with Jason next. And then we're pulling this into a 3-year roadmap to improve the performance of all of our homes. So I guess that puts us as a bit more of a first mover in the volume building segment. And we see that consumers will become more comfortable as green building enters the mainstream. But it's really unlikely that the rubber's going to hit the road until we've actually got that 75 litre per person water use cap, and we've got caps for that whole of life embodied carbon. And so when I think about the time between now and the end of the year, that's just over 100 days. Before that emissions cap for emissions reporting and an update to the building code for new buildings and putting in those caps is meant to be coming into play under MB's Building for Climate Change. So we hold our breath and hope for that release of that work stream. But in the meantime, I guess what LowCO has been is a bit of a call to action to support sector decarbonisation. I know I've been talking across many industry groups for the last several months about this. We've shared all of our plans publicly. You can download them from our website. And what it's doing is it's starting to ignite some really important conversations beyond a passive house. People who are already invested in building these high performance homes and putting it into the mainstream about what is the future of housing in Aotearoa. So thank you for your time. And you can use that QR code to get to the plan set and the construction videos. Thank you.